Rebecca Barnes. She was advised by Melinda Frick and by me, and she went to the University of Granada. Her majors are comparative literature.
Not anymore.
Not anymore. So what your majors are Spanish and French. What's the other major?
Linguistics.
Linguistics, Spanish and French. And she's going to be talking to us about what type of bilingual can anticipate a code switch.
Can you guys, can you hear me?
Yep. Yeah.
Hi, my name is Rebecca Barnes. I was in Granada last summer for 2 months. It was a wonderful experience. Again, I don't have as many pictures as Sethka did, I'm sorry. But so my experiment was called What Type of Bilingual Can Anticipate a Code Switch? And I'll explain the types of bilinguals, but it was really interesting to be in Spain and to be talking to all these students and having the opportunity to work with them. So yeah, okay, let's get started. So this was where we were working. This was the center of, this was the Linguistics Center, and it was a big building with a beautiful view and had the view of the city, and it was a really, really cool building. Okay, so my experiment is based off of a previous study that suggested that bilinguals who are experienced in code switching, that's switching between Spanish and English, can predict a code switch in a sentence using 2 types of phonetic cues. The first of which is a slower speech rate, which is pretty self-explanatory, but the second is a changed voice onset time. Now, for those of you who don't know, a changed voice onset time, a voice onset time, refers to the time it takes to produce a stop consonant. The 3 stop consonants would be p, t, and k. And in the case of these phonetic cues, a changed voice onset time would be manifesting itself in like a Spanish accent, essentially, in the p, t, or k. Like an English stop consonant is a little more relaxed than a Spanish stop consonant. It's very terse in Spanish. It would be a p versus a p. So if you have any questions, I'm sorry, that was, yeah. So the goal of the study was to see whether or not bilinguals who are not affiliated with code switching can also use these phonetic cues to predict a code switch in a sentence. And the research questions were basically asking about the roles of code switching experience and language dominance in both languages, and how those play a role in their use of phonetics as well. So I had 3 groups of participants. The first group were the code switchers that I was talking about. They are individuals who have grown up in a bilingual household and are used to switching between Spanish and English in very quick situations. I'll be calling them code switchers throughout this presentation. The second group of participants were non-code switching English dominant individuals. These were Penn State students studying Spanish as a second language. And I will be referring to them as L2 Spanish listeners or Penn State students, depends how quickly I'm talking. And then the third group of individuals were the people in Granada that I was testing in Granada. These were non-code switching Spanish individuals who are immersed in Spanish and studying English as a second language. Take note that neither of those last 2 groups of participants are used to code switching in their normal daily environments. And again, this is a picture from the laboratory. That was the eye tracking equipment we were using. This was actually the outside room. There was a room on the inside where the participants were sitting, and then that's where I would sit and watch their eyes move. So the experiment itself was an eye tracking experiment. The participants would sit through 384 trials of picture naming. And they would be listening to 1 of 3 instructions on each trial. The primary instruction was a natural code switch. In this case, we are click on the picture of the pato. We have a natural code switch in which from click to that's the English carrier phrase, there are phonetic cues. And the changed voice onset time that I explained earlier was manifesting itself in the P of picture. Essentially, the speaker was saying, click on the picture of the pato, and she was changing her voice onset time in that P instead of, I'm sorry. And then the listeners would predict the code switch at the end of the sentence using that changed voice onset time. The second type of instruction that they would listen to were the unilingual English phrases. Click on the picture of the pot. Obviously, there is no code switch, thus there are no phonetic cues in the carrier phrase. The third type of instruction that the participants were listening to was an uncued code switch, which is essentially an artificial code switch, in which we took the English carrier phrase of a unilingual English instruction, no phonetic cues, and put the pato from the cued code switch at the end of the sentence. In this case, the participants were listening to the uncued code switch. They would not detect the phonetic cues, and then they would be presented with a code switch, and we wanted to see how that would affect their perception of the instruction. So as they were listening to these instructions, they were presented with 4 pictures. In this case, click on the picture of the pato. The target is our duck, our pato. And we have also a pot, which is known as a unilingual distractor. In this case, unilingual distractor is a word that also begins with a stop consonant, and the participants, if they were listening to the phonetic cues and using them correctly, would not be distracted by the distractor because they would know to anticipate a code switch instead of an English word at the end of the sentence. However, if perhaps they were registering the phonetic cues and not using them correctly, or not registering the phonetic cues, we would know, it would be suggested by their proportion of looks to the interlingual distractor versus the target. So our predictions were essentially that the Penn State students and the code switchers would be most sensitive to these phonetic cues because they were presented in the English carrier phrase. And those were the 2 groups of participants that were most dominant in English. Whereas we thought that the Spaniards really wouldn't be as sensitive to registering these phonetic cues because English was not their first language. So, this is the first of our results. I'm sorry, it's a pretty daunting graph, but I'll break it down for you. It's pretty simple. We have 3 columns, and 1 corresponding to each of my participant groups. The first of which is the code switchers. Then we have the L2 Spanish listeners. Those are the Penn State students. And then we have the L1 Spanish listeners, which are the Spaniards. And then the rows, here we have the absence of interlingual distractors, and here we have the presence of interlingual distractors. Now, these lines are referring to the proportion of looks of the participant to the target on each trial. And the red lines refer to phrases in which they had a cue, and the blue lines refer to phrases that were uncued. If I can draw your attention to the top left corner, it seems that the code switchers had a higher proportion of looks earlier on in the trials to the target when they had the cues to help them and when they had no interlingual distractor. But essentially, it was the same curve throughout without the interlingual distractor. Here we have the L2 Spanish listeners, which were seem to be giving a higher proportion of looks to the target later on in the trial without the interlingual distractor. And then it seems that the L1 Spanish listeners really were pretty unaffected by the presence or absence of a cue because they were just giving the same proportion of looks throughout. Down below, when the interlingual distractor is present, we see the biggest change. In code switchers, it becomes more evident that they were giving a really high proportion of looks to the target when they had the cues to help them, and they were not paying attention to the interlingual distractor. Here, it seems that the L2 Spanish listeners were doing the same thing, but it just took them a little bit more time to register, because as you can see, the code switchers reacted very quickly, and then the L2 Spanish listeners reacted a little bit later in the trials. And then the L1 Spanish listeners kind of threw us a curveball. They were looking at the uncued, they were looking at the target more in uncued phrases than cued phrases, which was the opposite effect as we intended. Here we have 3 more graphs about their proportion of looks to distractors as opposed to the target. The circles here indicate that there was a presence of interlingual distractors, and then the X's are just unrelated trials. And again, the color coding is the same: blue for uncued phrases, red for cued phrases. For the code switchers, as you can see, when they had the phonetic cues to help them, they were paying a lot less attention to the distractors in cued phrases versus uncued phrases, and that's indicated because the red line is below the blue line. L2 Spanish listeners, it's the same thing, essentially. They were paying less attention to the distractors when they had the help of the cues, but it was relatively higher than with the code switchers, which goes with the other graphs as well that they were essentially registering these phonetic cues, but just a little slower to use them. And then the L1 Spanish listeners, again, defied all odds and were using, they were looking more at the distractors on cued phrases than uncued phrases, which heavily insinuates that they were registering the phonetic cues and then just were being really hurt by them. So yeah, the discussion, I mean, I can go through this pretty quickly, but the first point is what I said before, that the phonetic cues and the interlingual distractors will affect their perception, and then the language dominance and code switching experience does seem to play a role. Conclusion, it seems that the L2 Spanish listeners were hearing the phonetic cues, but were only using them when the distractor was present, because that's the only time we saw such a distinct change in reaction. And then L1 Spanish listeners, those were the Spaniards, they were taking the same amount of time to click on the target with or without phonetic cues, so it just seemed that they weren't using them or weren't registering them. Oh, and thank you to Teresa Rajo's lab, by the way. It was an honor to work with you. So.
Maybe there is time for one question.
We have 2 minutes.
Oh, 2 minutes. Okay. 1.5 questions.
Yeah.
Why do you think the Spaniards might have been throwing you a curveball and behaving as they did?
Well, as we predicted, we didn't think that they would be able to register those phonetic cues at all. So the fact that it was so regular, the data indicated that they were so regularly doing the opposite of what we intended with the phonetic cues, that they were registering some sort of change in the voice onset time, but it was hurting them. So we don't really know why. We were thinking of, trying to explore that in some other way, but it totally defied all odds that they even registered it. So.
I'm just wondering about the fact that they might be exposed a lot more to Spanish accents in English.
Right.
And therefore might be treating that a little differently in how they form their predictions.
Yeah, that's true.
I have a half question.
Okay.
So,
Is there time for a half question?
A quick one.
yeah, so a follow-up on Mike's question. So maybe you could look at the Spanish performance as a function of their L2 proficiency. So more experience with English, they might be able to detect the cues better.
Yeah, that's true. And Melinda actually had me, Dr. Freaky actually had me run a different experiment, but I was doing the same thing with the phonetic cues. I was switching it, and it's like a lack of code switching experience that I have on my part, and it was interesting. So.
There's a lot of benefits.
All right. Thank